Hello, these are the questions and answers on organic chemistry. I hope you've tried these questions so that we can go through their answers. The first question that you had was draw the displayed formula of an alkene containing 4 carbon atoms. So first of all, he wants an alkene, and remember, an alkene is the one that has what? It has a double bond between 2 carbons, and I want a total of 4 carbons. So this is what you should have done, and you can put the double bond either on that end or on the other end, and it's exactly the same. Or actually you can put the double bond anywhere, but make sure that each carbon does not have more than 4 bonds coming out of it. So each carbon cannot have more than 4 lines coming out. Okay, what is the general formula of the alkanes? Remember, we said there is something called general formula, structural formula, displayed formula. Here he wants what? He wants the general formula, and the general formula is the one that has N in it. So alkanes is CnH2n plus 2. We said the number of hydrogens is always twice the number of carbons plus 2. State 2 other features of a homologous series. So we said members of the same homologous series have the same general formula and the same what? The same functional group and same chemical properties. These are the 3 properties of members of a homologous series. Same general formula, same functional group, same chemical properties. The displayed formula below represent isomers. Explain what isomers are. Remember what are isomers? We said isomers are organic compounds having the same molecular formula but different displayed formula or different structures. Remember, what are we talking about? We're talking about same molecular formula but different displayed formula. The table shows the displayed formula of some organic compounds. Explain why all of these compounds are described as hydrocarbons. What do we mean by hydrocarbons? They are hydrocarbons because they contain carbon and hydrogen only, and the word only is essential. There is a mark out of these 2 that is just for the word only. Okay? Why are B and E described as unsaturated? So we look at B and E. What is B and E? They are unsaturated because they have a C double bond C. Remember that the word unsaturated means they have a C double bond C, or a double bond between carbons. Which letter represents the first member of the homologous series of alkanes? Remember that the first one of alkanes is the one that has 1 carbon. So which alkane here has 1 carbon? So that is, of course, A. That's the one we call methane. Which letters represent compounds that have the empirical formula CH2? Remember that we said, what is empirical formula? It is the one showing the simplest ratio. So you're looking for compounds that have the hydrogens twice the carbons. Of course, when hydrogens are twice the carbon, so actually you're looking for basically something that's an alkene or something similar in which the number of hydrogens is twice the number of carbons. So which ones? If you look at B and E are alkenes. And remember, we said the general formula for alkenes shows that the hydrogens are twice the carbons. But you also have F, because F is something which is what we call a cyclobutane. So it also has the number of hydrogens twice the number of carbons. What is the name of compound C? Where is compound C? How many carbons does compound C have? It has 4 carbons. What functional group does it have? It has a double bond, so that is called butene. If you want to be more specific, the double bond is on the first carbon, so you can say but1-ene or 1-butene. What is the molecular formula of compound C? So molecular formula, remember, which one is molecular formula? Molecular formula is the one showing the total number of carbons and total number of hydrogens. So the molecular formula for that is C4H8. Draw the displayed formula of an isomer of compound C. Remember that we said isomer of an alkene means The same number of carbons, but you put the double bond somewhere else. So instead of on one end, you're putting it in the middle. So that's your answer. Were you able to get all of this? Okay. So bromine water can be used to distinguish compound A from ethane. Of course, I look at compound A and I find that compound A is what? It's an alkene. Okay, complete the sentence to show the color change when compound A is bubbled through bromine water. So bromine water, if you put an alkene through it, bromine water changes from orange to colorless. That was the test for alkenes. Complete the chemical equation for the reaction between compound A and bromine water. Compound A is an alkene, and we said when you add something to an alkene, you open the double bond and you put something on this carbon and something on that carbon. So if you're reacting it with bromine, that means you're putting Br and Br. So that means you are adding 2 Brs to the C2H4. So that is your product. If you draw it out, that's fine also. Use the letters above to select the compound that's not a hydrocarbon. Remember that we said hydrocarbon means carbon and hydrogen only. So if it's not a hydrocarbon, then it is something that does not have carbon and hydrogen only. So S is the one that has an extra bromine. One compound with the empirical formula CH2. Again, empirical formula CH2 means the number of hydrogens is twice the number of carbons. So basically, you're looking for an alkene or something in which the hydrogens are twice the carbons. So the alkenes in this case can be T or U. One compound that can form a polymer, we haven't talked about polymers yet, but I will tell you that a compound that can form a polymer is the one that has a double bond. So anything that has a double bond would be your answer. Okay, cracking can be carried out in the laboratory by passing the vapor of an alkane over a heated catalyst using the apparatus shown. So remember what's cracking? We said cracking is breakdown of long chain hydrocarbons into shorter chains. So he's saying when decane is cracked, a shorter chain alkane and ethene can be produced. So write a chemical equation for that. So he's starting with decane. Decane is C10H22. I'm breaking it up into, he says it will give me ethene, so C2H4, and something else. So it is the rest of the carbons and the rest of the hydrogens. If you have C10H22, you remove from it C2, that means you're left with C8. The H22, you removed 4 from it, so you're left with H18. Easy, basic subtraction. Okay, the alkane produced can be used as a fuel for cars. When this fuel is burned in a car engine, some incomplete combustion occurs. This produces carbon monoxide, which is dangerous to humans. Explain why carbon monoxide is dangerous. And you remember why carbon monoxide is dangerous? We say it is dangerous because it is toxic or poisonous. And why is it toxic? Because it reduces the capacity of blood to carry oxygen. Ethanol can be manufactured by 2 different methods. The table gives some information about these 2 methods. In method A, ethanol is formed in the final step. Identify the 2 compounds that react together to form ethanol. If he's making ethanol from crude oil, we said, remember there were 2 methods of making ethanol. The one from crude oil is the one that makes ethene. So I get ethene from crude oil, and then what do I add to ethene to make ethanol? I add water. 2 conditions for this reaction. When we add water to ethene, we said this method is called hydration of ethene. What were the conditions for hydration of ethene? If you don't know these things, please go back to the notes, study them, go back to the video on this chapter and study it. It's very important. You should remember these conditions. So conditions for adding water to ethene are phosphoric acid catalyst, that is called phosphoric acid catalyst, and 300 degrees centigrade. The equation for the reaction that occurs in method B is this. So method B is the one where I start with glucose and I add something to it, it changes it into ethanol. Name the compound with the formula C6H12O6. You should know even from biology, but we also discussed this, that C6H12O6 is glucose. Identify the main impurity in the ethanol formed in this reaction. Remember that the glucose is originally dissolved in water, and then we add yeast to it in order to change it to ethanol. The main impurity when you have the ethanol is the water, because then you need to do fractional distillation in order to separate it from the ethanol and get the pure ethanol. Some of the ethanol produced by method B is converted into ethene. Now, this is where you're starting with ethanol and you're changing it into ethene. The ethanol, changing it into ethene, we said this is a reaction called dehydration. Now, what was the catalyst in this reaction? The catalyst in this reaction is aluminium oxide, or you could call it alumina. The type of reaction, we said this is removing water from something, so this is called dehydration. Write the chemical equation for this reaction. That's the equation that you have up there, so you can write it the way I wrote it up there, or you can write it C2H5OH to give C2H4 plus H2O, and remember that as it is balanced. Okay, the next question says bitumen, diesel, gasoline, and refinery gases are some of the fractions obtained from crude oil. Which one of these fractions has the lowest boiling point? So let's remember. Do you remember this? You're supposed to know the names and the order and the uses of each of these fractions. So we said when we have this in the fractionating column, the ones at the top are the ones that have less number of carbons, lower boiling point, less viscous, more flammable. So if he says which one of these has the lowest boiling point, you're looking at which one of these is at the top of the fractionating column. So that is the refinery gases. Which one of these is the most viscous? We said the most viscous would be the one at top or the one at the bottom. The one at the bottom. So the one at the bottom is the butane. Explain how the separation of crude oil into fractions takes place in the fractionating column. So he's asking you to explain what happens in the fractionating column. What happens in the fractionating column is basically you're supposed to explain that the crude oil first is heated, vaporized, goes up the fractionating column where it is cooled and condensed to give different fractions at different boiling points. And then you need to explain that the one with the lower boiling point is the one that is collected at the top. Polymers can be classified as addition polymers or condensation polymers. An addition polymer can be formed from the monomer C3H6. Now he's saying name this monomer and the addition polymer it forms. So if I have C3H6, what is that? Remember that C3H6 is propene. This is something that has 3 carbons, so that is prop. And the hydrogens are twice the number of carbons, so that is an alkene. So this is called propene. Now the polymer made from propene would be called polypropene. We said it's called poly, exactly the same name. Explain why there are problems with the disposal of addition polymers. Remember that we said there are problems with addition polymers. First of all, they are non-biodegradable, so they are inert, so they accumulate in dump sites. And remember that here he's asking the disposal of the addition polymers, so just say they are non-biodegradable because they're inert, they accumulate in dump sites. The next question says superglues are liquid adhesives that easily form addition polymers, giving a solid that sticks objects together firmly. The repeat unit of a superglue polymer is shown. Draw the structure of the monomer used to make this polymer. Remember, if I have the name, or if I have, the structure of the polymer, how do I make the monomer? If this is the polymer, then to make the monomer, you remove the bonds on either ends and you put a double bond in the middle. That's how you make the monomer from the polymer. You're going back to the monomer. So you're going back to the one that has the double bond in it. Okay, just remove the bonds on either end and put a double bond in the middle. Nylon is an example of a condensation polymer. Describe one difference between a condensation polymer and addition polymer. Do you remember the difference between them? The main difference is, one of them is addition polymer is the only product. In addition polymer, the polymer is the only product, and in condensation polymer, we said the polymer is formed by removal of small compounds. So you're making the polymer and something else, so polymer and water, for example. If you want another difference, we said you could say that in addition, the monomer is an alkene, while in condensation, the monomers have active groups on both ends, or functional groups on both. The table shows percentages by mass of the fractions obtained from a sample of crude oil and the percentage market demand for these fractions. Market demand, do you understand what market demand means? How useful or how important it is economically. Why is the market demand for the gasoline fraction greater than that for the fuel oil fraction? So why is gasoline more important than fuel oil? Remember, what are they used for? You should remember that gasoline is used as fuel for cars, while the fuel oil is used as fuel for ships. So we have many more cars that need a lot of gasoline. Cracking is used to make long-chain hydrocarbon molecules into shorter-chain hydrocarbon molecules. Complete the equation to show the other hydrocarbon molecule formed when C20H42 is cracked. So if you're starting with C20 and he's removing C16, you're left with C what? C4. You're starting with H42, you removed H34, then you're left with H8. That's all, just subtraction. Give the name of a catalyst used in industry to crack something and state the temperature. So what we said, what was the catalyst for cracking and what was the temperature for cracking? The catalyst was aluminum oxide or alumina. The temperature was 600 to 700 degrees centigrade. Again, please remember conditions. Give two advantages of making ethanol from ethene rather than by fermentation. Remember that we said we make ethanol either by hydration of ethene or by fermentation of glucose. So what is the advantage of making it from ethene? Remember we said ethene, making it from ethene. This is a faster reaction and the product that is obtained is a pure product. So just two reasons why ethanol is sometimes made by fermentation rather than from ethene. So when will it be useful to make it by fermentation? When the land is available to grow sugarcane, and sugarcane is a renewable resource, so that's good for the environment. Needs lower temperature, so that means less energy is needed, that means it is cheap. So that's why we could make it by fermentation. A teacher discussed with her students whether the boiling points of organic compounds are related to the size of their molecules. The students suggested measuring the boiling points of some organic compounds using this apparatus. So this is a test tube where he puts the organic liquid and he's heating it with a Bunsen burner. Is that a good idea? You should remember when we talked about safety precautions, organic liquids are flammable, they burn easily, so you don't heat them directly by a Bunsen burner. Now, the teacher said that their suggested method was too dangerous. She recommended using the apparatus shown below, where you put the container on a hot plate. So you're not using a Bunsen burner, you're not using open flame. So just one reason why this apparatus is better than the other one, which you had a Bunsen burner under the test tube. Of course, this is because organic liquids are flammable and may catch fire. The students used the apparatus recommended by the teacher to measure the boiling points of 5 alcohols. So he has A, B, C, D, E, and he measured the boiling point of each one. Plot a graph of the data in the table on the grid. Draw a straight line of best fit through the points. So when you tried, did you try drawing this? You should have tried drawing this. When you plot it, it looks something like this. And he said, draw a straight line of best fit. That means you draw a line that takes or goes through as many of these points as possible. Okay, describe the relationship shown by your graph. Of course, this graph shows that as the relative formula mass increases, the boiling point increases. Use your graph to predict the boiling point of alcohol that has relative formula mass of 74. So you look at the graph, you look at 74 down, you go up, up, up to the line, and you go horizontally, and you find that it is at 116 degrees centigrade. Which of the alcohols is the least volatile? Now let's think. Least volatile means evaporates, does not evaporate easily. We said volatile means evaporates easily. He's saying least volatile. Least volatile means does not evaporate easily, and that means you're looking for something with a high boiling point, and the one that is the higher boiling point is E. Do we understand that? Ethanol can be converted into chloroethene in 3 stages. Now, you see something you haven't seen before? Don't panic. He's giving you the instructions. So he's saying stage 1, ethanol is dehydrated to form ethene. Ethene is converted into 1,2-dichloroethane, and 1,2-dichloroethane is converted into chloroethene and hydrogen chloride. Now, what is the question? Why is the reaction in stage 1 described as dehydration? He started with ethanol to form ethene, and that means when you have ethanol and you're trying to form ethene, that means you're removing water, and that is called dehydration because it involves removal of water. Identify the catalyst used. Catalyst, when you remove water from ethanol, is aluminum oxide or aluminum. So remember that we had aluminum oxide as a catalyst for 2 things, 2 reactions. The first one was this one, removing water from ethanol in order to change it to ethene, and the other one was in what? In cracking. He said the catalyst for cracking, where you have a big long chain and you're breaking it up into 2 or more. Also, your catalyst was aluminum oxide. Suggest the name or formula of the substance used to react with ethene in stage 2. So let's go back to stage 2 up there. It says ethene is converted into 1,2-dichloroethane. So you're starting with ethene and you're changing it into something that has a chlorine on both ends of the double bond, and that means you're reacting it with chlorine. You have to react it with Cl2 in order to open up the double bond and put a Cl here and Cl there. Write a chemical equation for the reaction in stage 3. Now, he already gives you the information for stage 3. He says 1,2-dichloroethane, that's the one written in stage 2, is converted into, so 1,2-dichloroethane, he already gives you the formula. Converted into means an arrow, into chloroethene, and he gives you the formula of chloroethene up there, plus hydrogen chloride, which is basically HCl. Okay? Chloroethene can be used to make the polymer polychloroethene. The displayed formula for part of the polyvinyl chloride molecule is this. Draw a displayed formula for a chloroethene molecule. Now, first of all, even if you don't know how to draw chloroethene itself, he's saying draw the monomer of this polymer. And we said, first of all, you need to look at the repeat unit, the unit that is being repeated. Can you see that this part is being repeated 3 times in that molecule? So that is the part that you need to use to make the monomer. And we said to make the monomer, you remove the bonds on both ends of the carbons and you put a double bond in the middle. So this is basically what you have. Describe in terms of structure and bonding what happens when chloroethene is converted into polychloroethene. Again, when I have a monomer and I change it into a polymer, what do? The C double bond C in the monomer is broken to form a single bond, and then the single bonds, new single bonds, are formed between the monomers to form a long chain. Do you remember that? Okay. The table gives some data about the first 6 members of a homologous series of compounds called the alkanes, and he gives you a table and he says complete the table by giving the molecular formula of hexane. Where is hexane? Hexane is the last one in that table. What would be its molecular formula? This is an alkane. So hex means 6. Now the general formula was the one where we have 2n plus 2. So this is C6H14. Giving the relative formula mass of butane. Where is butane? I want the relative formula mass. How do I calculate relative formula mass? That's the same as molecular mass. So molecular mass is 4 times the molecular mass, the atomic mass of carbon. So that means 4 times 12 plus 10. So that is 58. Suggest the boiling point of pentane. Now, how do you suggest the boiling point of something? If you have a list of information like this, you need to know what is the difference between each of these in order to determine how much different the pentane would be from the one above it or the one below it. So if you look at this, you will find that the estimation for this could be anywhere between 25 and 45. Any number of between that would be a correct answer. What does the data show about the relationship between boiling point and the relative formula mass? Now, what is happening to the boiling point as the relative formula mass increases? As the relative formula mass increases, the boiling point increases. Molecular formula of ethene is this. Ethene and ethane are in different homologous series. Explain how the formula of these compounds show that they are in different series. So if I say that ethene is C2H4, ethane would have a different what? It will have a different general formula because ethene, the general formula is CnH2n, while the ethane, that's an alkane, the general formula is CnH2n plus 2. So from their formula, the fact that ethene, the hydrogen is twice the carbon, while the ethane, the hydrogen will be twice the carbon plus 2. In the table, draw displayed formula of the two alkanes with the molecular formula C4H10. So C4H10, these will be your answers. C4H10 is something that has 4 carbons. So either all the 4 carbons are in one chain, and this is called a straight chain formula, or it will be branched in which you have 3 behind each other and one of them is attached to the middle. Okay, what is the name given to compounds that have the same molecular formula but different displayed formula? Do you remember that? We said same molecular formula, different displayed formula are called isomers. The reaction between ethane and bromine is similar to the reaction between methane and bromine. Write a chemical equation for the reaction between ethane, so that's an alkane. Remember that we said when alkanes react with halogens, what happens? This is a reaction in which one of the hydrogens is replaced by one of bromine, and that means I'm left with that hydrogen that I removed plus the other bromine. So this is the reaction for alkane with bromine. What is the name given to this type of reaction? Remember, when alkane reacts with halogens, this is called a substitution reaction. What was the conditions for the substitution reaction? UV light. You have to remember. Production of polymers from crude oil involves several processes, including fractional distillation, cracking, purification, polymerization. 3 of the fractions obtained from fractional distillation are these. Identify which of these fractions has the darkest color. Again, when you remember this diagram, you should remember this diagram. The darkest color is the one at the top or at the bottom. You have to remember that as I go down, the color gets darker. So the one with the darkest color is the one that is at the bottom. So that is the fuel oil. Remember, he's talking about fuel oil, gasoline, and kerosene. Where are all of these? Fuel oil, gasoline, kerosene. So the one at the bottom is the fuel oil. That would be the darkest color, the higher boiling point, the more number of carbons, the more viscous, the less flammable, and so on. Identify which of these fractions has the highest boiling point. Also, the one with the highest boiling point is the one that is down. Identify which of these fractions contains molecules with the fewest carbon atoms. Fewest means less number of carbons. That's at the top. So the one at the top would be the gasoline. Remember, you're choosing from the 3 choices that he gives you: fuel oil, gasoline, and kerosene. Okay. Cracking involves heating some of the fractions to about 650 degrees centigrade. Name a catalyst for cracking. What was the catalyst for cracking? Aluminium oxide. One reaction that occurs in cracking involves the conversion of one molecule of this into one molecule of octane and so on. Complete the equation. So he already gives you, he says the molecule of hexadecane, that's the one that he gives you there, into one molecule of octane. He already wrote it for you, C8H18, and what? And two molecules of an alkene. Two molecules of an alkene. So here you're not just going to say 16 minus 8 is what and 34 minus 18 is what. Actually, you need two molecules of something so that when you multiply it by 2, it gives you what you want. So C16 minus C8, that's 8. So I need a total of 8 carbons, but that means that I have 2 that have C4. 34 minus 18 is 16, but that means I have 2 times 8. So remember, it is the trick in here is the fact that you need 2 molecules of an alkene. Give 3 reasons why cracking is carried out. Remember that we said cracking is an important process. Why? First of all, produces shorter chain hydrocarbons that are more useful and more in demand. The shorter chain hydrocarbons have higher prices, so more profitable economically, and it produces ethene, which is important to make polymers and ethene. One of the compounds sometimes present in crude oil has this formula. Explain why it's important to remove this compound from a fuel. So this is something that has sulfur. And sulfur, when burnt, it produces sulfur dioxide gas that causes acid rain, that kills plants and marine animals and dissolves buildings. We haven't done acid rain yet, but you probably know this from your studies in the previous year. One compound obtained from crude oil is used as a monomer in polymerization. It has the displayed formula, this. Now complete the following structure to show a part of the polymer formed from this monomer. So remember, how do I draw a polymer? First of all, I look at the part that has the double bond, and I put it as a single bond, and I put a line from a bond from this side and one from this side, and then I look. The first carbon is bonded to 2 hydrogens, then the second carbon is bonded to a hydrogen and a carbon that is bonded to 3. But then he puts 4 carbons. So that means that he wants you to draw 2 repeat units. So he wants you to repeat that part a second time. So that's how you draw this. The diagram shows some important conversion processes used in the oil industry. Process 1 is called what? So what is process 1? Process 1 is changing crude oil into kerosene. And remember, when I start with crude oil, what is the first thing that I do to it in order to separate it into fractions? I separate it using fractional distillation. Can you see that X? I'm sorry, the X is not very clear. But your answer is C. Describe the differences between crude oil and kerosene. In your answer, you should refer to the size, the covalent bonding, and the viscosities. So, crude oil is the original petroleum. That is a mixture of many hydrocarbons, while kerosene is one of the fractions of the crude oil. So, which one would have bigger molecules? Remember that the crude oil, the petroleum, is the one that has larger molecules, more covalent bonds, higher viscosity than kerosene, because kerosene is just a fraction of it, is a part of it. Okay, the equation for one reaction that could occur in process 2 is this. Deduce the formula of C6Hy. How do I get CXHY? Sorry, CXHY. So CXHY is the total of what I got. Now what did I get? I got 1 with 5 carbons, and I got 2 with 2 carbons. That means I have a total of 4 plus 5, that is 9. So this is C9H, how many? 2 times 4, 8 plus 12, that's 20. So that is the total number of carbons that you ended up with and your total number of hydrogens. Give the name of the compound C5H12. C5 means the name must start with Pent. Now, is this pentane or pentene? Well, let's look at the hydrogen. Is the hydrogen twice the carbon or more than twice the carbon? If it is twice the carbon, it's an ene. If it is more than twice, then it is pentane. So this is more than twice the carbons, so this is pentane. Draw the displayed formula of C2H4. How do we draw C2H4? 2 carbons with 4 hydrogens. That means I have a double bond in order to make each carbon have a total of 4 bonds. Okay? The structural formula of chloroethene formed in process 3 is this. The polymer formed in process 4 is polychloroethene. Draw the displayed formula for the repeat unit of polychloroethene. So basically you're trying to draw the polymer of that compound that he drew there. So let's draw that compound first. You have a carbon with 2 hydrogens and a carbon with 1 H and 1 Cl. So that's the monomer you're starting with. Now what would be the polymer? The polymer means we open the double bond, make it a single bond, put a bond from this side and a bond from this side, and we close it with a bracket and N. This is the formula for the polymer. Okay? Polychloroethene and nylon do not biodegrade easily. We said, remember that the problem with the polymers is that they are non-biodegradable. Now, what is meant by the term biodegrade? Remember, we said biodegrade means this is biodegrade, not non-biodegradable. We said non-biodegradable cannot be broken down by bacteria. But when I say biodegrade, it can be broken down by bacteria. What feature of addition polymers makes it difficult for them to biodegrade? Why is it that polymers are not biodegradable? Because it is inert. The word inert means unreactive, does not react. The alkane C5H12 has 3 isomers, and he gives you one of these isomers and he says draw the displayed formula of the other 2 isomers. So these are 5 carbons. You can either draw all the 5 carbons behind each other in a long chain, or you can draw it branched. Now he already has one branch where you have 3 all together and 1 up and 1 down. So you can put 4 in a chain and then one of them is branched. An industrial chemical company has supplies of ethene and ethanol. The company considers using these 2 processes, converting ethene to ethanol and then converting ethanol to ethene. A chemical equation for this process 1 is this, where he's changing ethene to ethanol. Now, which conditions does the chemical company use in process 1? If I have ethene and I want to add water to make it ethanol, what were the conditions? Do you remember? Was it aluminum oxide catalyst? No, we said aluminum oxide catalyst is used for 2 things, either for cracking or for changing ethanol to ethene, which is process 2, not process 1. A pressure of 65, yes, that's the answer, and the X should be there. So a pressure of 65 atm, that is one of the conditions of hydration of ethene. Remember that what were the conditions for hydration of ethene? Adding phosphoric acid as a catalyst. Temperature 300 degrees centigrade and pressure of 65 atm. Draw the displayed formula of ethene and ethanol. So this would be the diagrams that you should draw for ethene and ethanol. Why is it correct to describe ethanol as saturated but incorrect to describe it as a hydrocarbon? Where is ethanol? Okay, is that saturated or not? We said saturated means what? Saturated means it has only a single bond between the carbons. Now, what does hydrocarbon mean? Hydrocarbon means it has only carbon and hydrogen. Does it have only carbon and hydrogen? No. So it is saturated because it has no C double bond C, or it has only C single bond C. And it's not a hydrocarbon because it does not contain carbon and hydrogen only. Okay? Process 1 says converting ethene to ethanol. Process 2, converting ethanol to ethene. The question says a scientist working for the chemical company makes the following predictions that could affect processes 1 and 2 in future. So he says crude oil will be less available, more expensive, the climate will be warmer and allow more sugarcane to be grown. suggest how each of these predictions will affect the two processes. Now, if crude oil is less available, would process 1 be a good idea? Where do we get ethene from? If he's trying to convert ethene to ethanol, we get ethene from crude oil. So if crude oil is less available, more expensive, then process 1 will be more difficult. Now, if the climate will be warmer and allow us to grow more sugar cane, and I can get from the sugar cane, I can get glucose, and from glucose I can make ethanol, and from ethanol I can make ethene. So first of all, crude oil is less available, more expensive. So process 1 will not be possible since crude oil is needed to obtain ethene by fractional distillation and cracking. Now, if I say the climate will be warmer and allow more sugarcane to be grown, then process 2 will be preferred. Sugarcane is used to obtain ethanol by fermentation. Okay, decane is a hydrocarbon found in crude oil. So this is decane. Explain why decane is a hydrocarbon. Again, because it contains carbon and hydrogen only. What is the molecular formula? Please notice, is he asking molecular or general or empirical or displayed or so on? Molecular means what? You just add up all the carbons and add up all the hydrogens. So this is C10H22. Decane and ethene are produced during the cracking of this. Ethene is used to make polyethylene. So what is the name given to this type of polymerization? If I start with a double bond and I make polymer, that is called addition polymerization. Use the diagram to state two changes that occur during the formation of polyethylene. Again, when I start with an alkene and I'm making the polymer, what did I do? The double bond in the ethene is broken to form a single bond, and then new single bonds are formed between monomers to join them into a long chain. Okay, let's stop here and let's continue in a part 2 to this questions.